I want to paint a picture for you, and I am willing to bet you know exactly what this feels like.
Oh, I'm sure I do.
Right. Okay, so let's set the scene. It is exactly 4:45 p.m. on a Thursday.
The absolute danger zone.
It really is. You have been running this absolute gauntlet of back-to-back meetings since like 8:00 a.m.
You're just totally depleted.
Exactly. You've navigated 3 different time zones, you've put out a half dozen operational fires, and your cognitive reserves are just utterly gone. I mean, your brain essentially feels like it's made of wet cotton.
Yeah, decision fatigue is so real at that point in the day. Your prefrontal cortex is basically running on fumes.
You are literally just staring at the clock on your monitor, waiting for the day to finally mercifully end. And right at that exact moment, an email drops into your inbox.
Of course it does.
It's an automated report, right? Generated by your company's flashy new internal AI system. And it's supposed to synthesize 40 different incredibly dense PDFs.
Something massive like Q3 market analysis or cross-border compliance reports.
Yeah, or legal briefs for a new product launch, whatever it is dense. So, bracing yourself, you double-click the attachment, you open it up, and what you see on your screen is just an absolute thing of beauty.
Oh, that visual relief of a perfectly formatted document.
It's flawless. I mean, the margins are perfect. The bullet points are crisp. They're syntactically parallel, evenly spaced.
It looks finished.
It looks so finished. There are these bolded, authoritative headings that just guide your eyes effortlessly down the page. The tone is definitive, professional, and just aggressive in its certainty.
And your body actually reacts to that before your brain even processes the words.
Yes. Sitting there at 4:45 p.m. staring at this pristine artifact, you experience this immediate physical lowering of your shoulders. You just exhale.
Because the immense cognitive load of processing 40 PDFs just vanishes.
Completely vanishes. Because the document is signaling to you, visually and structurally, that the hard analytical work has already been done on your behalf.
Which is such a powerful and dangerous illusion. When an output looks aesthetically complete, we have this really deep-seated psychological bias to treat it as factually complete.
Right.
We are literally wired to conflate legibility with accuracy.
And I will happily admit, I have fallen into this trap.
Oh, we all have.
I've received one of these perfectly polished AI-generated summaries, and because it looked so professional, so utterly indisputable, I just, skimmed the bold text.
Nodded to yourself?
Yep, nodded, attached it to a new email.
Yeah.
And forwarded it straight to the VP of my division with a note saying, summary attached for review.
Let me guess. You didn't verify a single underlying link.
I didn't spot check a single cell of raw data. I looked at the font choice and the formatting, and I essentially hallucinated the rigorous analytical work underneath it.
Right, because you didn't verify the evidence. You borrowed the trust.
I borrowed the trust wholesale.
Yeah.
And, the inevitable consequence happened the next morning. The VP replies, zeroing in on a highly specific, massive discrepancy in one of the revenue projections.
Oh, no.
And the sheer panic that watches over you in that exact moment is visceral. You realize in real time that you have absolutely no idea what you just endorsed.
You staked your entire professional reputation on a set of claims that you basically acquired through aesthetic osmosis.
Exactly. And the immediate instinct for anyone in that situation is intense self-blame. You sit there thinking, I was lazy, I was rushing because it was Thursday.
I should have done the due diligence.
Right. You internalize the failure as this massive personal lapse in judgment. But what we are going to explore today is that while human fatigue obviously plays a role, what you experienced in that moment is not primarily a personal failing.
No, it's actually a massive systemic architectural vulnerability.
And that brings us to the core of what we are unpacking today. Welcome to the deep dive. We are drawing our source material today from a phenomenal, highly detailed post on Rooted Layers AI systems grounded in research.
It's an incredible piece of work.
It really is. And the tone of our discussion today is going to be like two researchers just thinking out loud, right? We want to take our time, be curious, and really dig into the mechanics of these systems.
Because the mission of this deep dive is to explore the mental models behind a concept that the researchers in the post call confidence debt.
Confidence debt. It's such a striking phrase.
It's an incredibly precise term. Confidence debt describes the systemic vulnerability that occurs when the usable output of an AI system moves faster through an organization than the empirical evidence required to support it.
Wow.
But, before we get into the deep mechanics of how this debt is generated, we really need to draw a hard boundary around what we are not talking about today.
Right, let's establish those parameters because the conversation around AI failures is usually pretty superficial.
Exactly. The mainstream tech conversation right now is obsessed with surface-level AI failures. You see endless articles about funny hallucinations.
Like a chatbot failing to count the letters in the word strawberry.
Right, or an image generator giving someone 6 fingers. The narrative is always framed as this localized error like either the machine made a dumb mistake or a specific user was just too disengaged to catch it.
But the post from Rooted Layers makes it very clear that confidence debt is something entirely different.
Completely different. We are not talking about generative bloopers here. This fits a broader pattern we're seeing across the entire tech landscape. We are talking about a fundamental paradigm shift in how organizations process reality.
It's an organizational failure where trust is borrowed against unverified evidence.
Yeah.
And that unearned trust compounds at every single step of a corporate pipeline until it triggers a total catastrophe.
Exactly. And to truly understand where this paradigm shift originates, we have to look at the exact moment the phenomenon was identified and named.
Yeah, because the researchers didn't just, invent the term confidence debt in some philosophical vacuum. It emerged from the wreckage of a highly specific, deeply technical project from 2025.
The IP Verify incident.
The IP Verify incident,
Mm-hmm.
led by Lambert Pallou and a team of just incredibly capable engineers.
And it is the perfect Genesis story because it beautifully isolates that variable of trust.
So let me set the context for you, the listener, because the scale of what Pallou's team was trying to do is genuinely staggering.
Yeah.
They were working on the Ethereum blockchain.
Right.
And for those who might not be deep into blockchain architecture, Ethereum is essentially this massive, decentralized, globally distributed computing machine.
Mm.
And the rules governing how it operates, the core protocols, are outlined in these incredibly complex, dense, human-readable English requirements.
And here's the catch. To actually make the blockchain function, those English requirements have to be manually translated into thousands upon thousands of files of highly complex C++ or Rust code.
Which is just an auditing nightmare. I mean, a human auditor might spend months looking at a single English rule.
Like, if a smart contract transaction fails due to insufficient gas, the state must revert entirely.
Exactly. And then they have to meticulously comb through this massive code base to find the exact line of C++ that definitively enforces that specific rule.
It's grueling work.
So the IP Verify project asked a very logical question. Can we use an advanced, deep research AI system to act as a bridge?
Can the AI read the English protocol, ingest the entire code base, and successfully map the obligation to the implementation?
Which, if successful, would completely revolutionize software auditing.
Oh, it would change everything.
Yeah.
But you are essentially asking a probabilistic model to perform deterministic verification.
Right, so they let the system loose on the repository. The AI runs its massive, multi-agent analytical process churning through the code. And at the end of the run, it generates two vastly different artifacts describing the exact same verification attempt.
And the divergence between these two artifacts is exactly where the entire theory of confidence debt is born.
So artifact number one was the dream. It was this beautifully polished, highly readable, aggressively confident summary report.
Formatted perfectly in Markdown.
Perfectly. Ready to be dropped straight into a public GitHub readme or presented to a funding board. It essentially declared total victory. Every single obligation in the Ethereum protocol has been successfully mapped to the underlying code. Here is the clean, synthesized overview.
It was the exact type of document that lowers your shoulders at 4:45 p.m.
Exactly. It visually signaled absolute completeness. But then there was artifact number two,
The reality check.
the raw receipt, the actual row-level evidence file generated by the system's tracing function. And it was a monstrously complicated, sprawling, deeply unfriendly spreadsheet.
No aesthetic relief whatsoever.
None. To even begin to verify it, a human engineer would have to manually open up specific code mappings, follow obscure repository paths, cross-reference function calls, and make deeply technical judgment calls about whether the C++ code the AI cited actually did what the AI claimed it did.
It required intense cognitive friction to process.
But to their credit, when Pallau's team realized they couldn't just trust the beautiful summary, they rolled up their sleeves and actually did that grueling work of parsing the massive spreadsheet.
And what they discovered was, frankly, terrifying.
The beautiful polished report was systematically and confidently lying.
Lying. It wasn't just suffering from minor formatting errors or like slight misinterpretations. The core logical mapping was fundamentally hallucinated.
The post outlines exactly how the AI failed, and it's fascinating. The AI claimed it had found the core protocol logic that enforced the blockchain's rules. But when the engineers looked at the actual code paths in the spreadsheet, the AI was pointing to entirely irrelevant parts of the repository.
Like ABI helpers.
Right. And that's a crucial distinction, isn't it?
It really is. In software architecture, an ABI helper, an application binary interface helper, is basically just interface plumbing. It's structural code that formats and translates data so that two different programs can communicate.
So it doesn't enforce any rules.
Exactly. It enforces zero core logic. It just passes the messages back and forth.
The AI also pointed to test fixtures. And a test fixture is basically a simulated environment used during development, right?
Yeah. Pointing to a test fixture to prove the protocol works is like pointing to a plastic crash test dummy in a laboratory and telling an auditor, look, here's a perfectly functioning human driver.
That is such a great analogy. It completely misses the point of the verification. And it also pointed to RPC glue, which is purely networking code.
A useful way to think about this failure is to imagine a corporate audit.
Okay.
An auditor asks you to provide undeniable proof that the CEO signed off on a massive, highly sensitive financial merger.
Right.
To provide this proof, you hand the auditor a log showing that the receptionist answered the phone when the CEO called the building.
Wow.
Right?
Yeah.
The receptionist is absolutely part of the communication pathway, but they possess zero decision-making authority regarding the merger. The AI system simply could not distinguish between the structural plumbing that moves data and the core logic that makes the decisions.
But it presented its wildly incorrect findings with the utmost authoritative confidence in that polished summary.
With zero hesitation.
And the actual data points from the Verified deep dive are just staggering to look at. In one specific model tier they evaluated, there were 15 entries that the team flagged as requiring a human to directly adjudicate them. Out of those 15, 13 required follow-up because the AI's initial mapping was demonstrably, fundamentally wrong.
A failure rate of 13 out of 15 on high-stakes code verification is catastrophic.
It really is. And it gets worse when you zoom out. Across a broader set of 81 scored mappings, the team tracked 8 explicit, outright contradictions between the confidence summary and the raw data.
Ouch.
The situation was so severe that the team had to formally downgrade 3 major claims that were intended to be public-facing, simply because the AI had entirely fabricated the mapping success just to make the report look better.
Now, if I am a listener with a background in software engineering, I'm probably thinking, okay, this is a fascinating anecdote, but AI models hallucinate. We know they are probabilistic engines that sometimes predict the wrong next token.
Right.
So why is this specific incident the poster child for a completely new structural theory of workflow vulnerability rather than just a plea to wait for the next iteration of the model to get smarter?
That is a very fair pushback. Why isn't this just an AI capability problem that will be solved by throwing $1 billion more of compute at it?
The answer lies in the core asymmetry of the generated artifacts. This is the crucial insight from the post.
Okay, break it down.
Every single verification workflow, whether it is executed by a human junior analyst or a trillion-parameter neural network, is going to contain errors. Humans make mistakes. Machines make mistakes.
Sure.
But the distinctive, catastrophic failure in the Verify case was that the wrong artifact was the incredibly usable one. The wrong artifact was the aesthetically pleasing, easily digestible one.
The asymmetry between usability and truth.
Exactly. Without an ironclad structural rule dictating how an organization handles these dual outputs, human nature and corporate momentum will irrevocably dictate what happens next.
Because the polished false summary is the artifact that is going to travel downstream.
Always. It is going to get attached to emails, copied into PowerPoint presentations, and used by executives to justify massive operational deployments.
Meanwhile, the messy, accurate, row-level spreadsheet remains technically available on a server somewhere.
But operationally, it is completely ignored.
Because the friction required to process it is just too high for a fast-moving corporate environment.
Precisely. And that specific asymmetry is the exact birthplace of confidence debt.
And the post makes a vital distinction here, too, separating confidence debt from 2 other really well-known concepts, technical debt and epistemic debt.
Right, because we need to know what we're actually dealing with. Technical debt is a conscious trade-off. It's when an engineering team deliberately writes sloppy, inefficient code to hit a launch deadline.
Knowing fully well they will have to pay a massive refactoring tax down the line when the system scales.
Exactly. Epistemic debt, on the other hand, is when you use a tool you don't fully comprehend. Like, if you use an AI to write a complex Python script and you deploy it without understanding the underlying math, you are borrowing the understanding.
Okay, so if technical debt is borrowing time and epistemic debt is borrowing understanding, what exactly is confidence debt?
Confidence debt is the act of borrowing trust.
Wow.
The downstream user, the VP receiving your email, the project manager reading the polished markdown report, assumes that because the document looks so structurally sound, someone, somewhere upstream, did the grueling cognitive labor of actually verifying it.
They assume the debt of verification has already been paid.
But no one paid it. The trust was manufactured purely by the aesthetic of the artifact. It was borrowed against unverified evidence.
That is a chilling realization. I mean, the downstream user is operating under the assumption that verification occurred simply because the artifact's presentation implies verification. The formatting itself acts as a proxy for rigorous auditing.
Which is why we have to examine the workflow architecture itself, rather than just waiting for the AI models to magically stop hallucinating. Human psychology ensures that the polished, false summary will always outpace the messy, true data.
And that brings us to the first major structural question. How do organizations stop this bleeding at the source? How do we secure what the researchers refer to as the first gate?
The artifact layer.
Right. If we accept that this asymmetry between usability and truth exists, how do we engineer a system to neutralize it? The reaction of the Ethereum team is highly instructive here.
It really is, because when they realized the AI was systematically lying in the summary, they didn't dive into the code base and attempt to tweak the model's temperature settings.
Or rewrite the system prompts to literally beg the AI to be more honest.
They recognized the futility of that approach. The model is a probabilistic prediction engine. You cannot fundamentally mandate absolute deterministic truth from a probabilistic system through a prompt constraint.
So what do? They built a rigid, unyielding cage around the model's outputs.
A structural cage.
Yeah. They instituted absolute, unbreakable local rules for their workflow. They established a doctrine that raw artifacts fundamentally and irrevocably outrank summaries. No exceptions, no executive overrides.
If there is ever a discrepancy between the beautiful markdown report and the messy spreadsheet, the spreadsheet is declared the ground truth.
Which is a profound structural shift for an organization. It explicitly strips authority away from the aesthetic presentation and anchors it entirely to the raw, auditable evidence.
And they also implemented a mechanism they called a contradiction register.
Right, I love this concept.
When the AI's fluent summary conflicted with the underlying raw data, for instance, claiming a function was mapped when the spreadsheet clearly showed it was just an ABI helper, that contradiction wasn't simply smoothed over or deleted by an editor to make the final report look more cohesive.
It was extracted, isolated, and turned into a tracked software object. A claim was literally physically blocked from moving forward into a public statement until its exact evidence state, including any recording contradictions, had been manually checked and cleared by an engineer.
This specific mechanism connects directly to a brilliant 2026 paper by Rashid and their team, which the Post highlights.
Yes, let's talk about Rashid's work.
Rashid's core thesis is that because deep research AI agents can now generate flawless, highly persuasive technical reports at practically zero marginal cost, generation is no longer the bottleneck in knowledge work.
We have achieved infinite, frictionless generation.
The new bottleneck is tracing.
Tracing
is the incredibly difficult, cognitively exhausting task of figuring out what exact, specific piece of empirical evidence supports this one beautiful sentence.
And conversely, what contradictory data was intentionally ignored or smoothed over by the AI's reward model to make this paragraph flow so perfectly.
Exactly. It's reverse engineering the AI's narrative choices.
So how does Rashid propose we solve this tracing bottleneck? Because it sounds overwhelming.
They demand that systems be built with specific, quantifiable metrics for what they call claim auditability. They completely reject the vague corporate buzzword of transparency and break it down into 4 rigorous targets.
Okay, let's go through them.
First is provenance coverage. This asks a simple binary question. is literally every single factual claim generated by the AI inextricably linked to an inspectable raw source document.
Every single sentence must have a receipt. That is an incredibly high bar for system design.
It is. Second is provenance soundness. Because just having a link doesn't mean the link is valid. Soundness asks, does the cited source actually say what the AI claims it says?
Right. Or did the AI wildly misinterpret the semantic meaning of the paper just to force it to align with its broader narrative?
Exactly. Third is contradiction transparency. If the AI ingested 50 sources and 5 of them vehemently disagreed with the other 45, did the AI surface that disagreement? Or did it bury the dissent just to appear more confident?
It usually buries it.
It loves to bury it. And the fourth metric is audit effort. How physically, temporally, and cognitively exhausting is it for a human being to actually navigate the interface and verify all of this provenance?
And that fourth metric audit effort brings us to what might be the most fascinating paradox in this entire deep dive.
Oh, absolutely.
Because if you are a software designer and you realize that tracing is the bottleneck, your natural instinct is to build a beautiful, seamless user interface that makes tracing effortless. You want to build a tool that does the work for the user.
It is the foundational impulse of all UX design. Reduce friction. Make it easy.
But the post details a study by Martin Boyle that completely shatters this assumption. The study focused on an interface tool called Paper Trail,
Right.
and it was designed specifically for AI-assisted scholarly research. On paper, it was the absolute dream interface. It automatically decomposed the AI's generated answers, cross-referenced them directly against the source papers, and visually surfaced the exact provenance.
It did all the heavy lifting.
All of it. Right there on the screen, it highlighted what was empirically supported, what was entirely unsupported hallucination, and what counter-evidence was omitted.
It provided the exact granular provenance that Rashid's framework demanded. It showed the human user all the receipts in a highly accessible format.
But the implementation of Paper Trail backfired completely.
Completely backfired. And the failure mode here is critical to understand. Why did perfect transparency fail?
Well, the granular transparency made the human readers significantly more skeptical of the AI's output. They saw the red highlights, they read the warnings about omitted counter-evidence, and they became highly suspicious of the summary.
Okay, so that sounds like a win.
It does. But, and this is the crux of the issue, that suspicion did not translate into corrective action. They did not actually engage in the hard manual work of fixing the errors or rewriting the summary. The researchers coined a term for this, the trust behavior gap.
So the users intellectually knew the AI was likely hallucinating, but their behavior remained completely unchanged. They still let the flawed output pass through the workflow.
Exactly. And a really useful way to think about this dynamic is the analogy of a nutritional label on a highly processed candy bar.
Oh, I love this analogy.
It's perfect, right? The label provides perfect, undeniable transparency. It tells you exactly how many grams of sugar and artificial dyes are in the bar.
You know exactly what you're eating.
Right. And reading that label might genuinely make you feel skeptical about eating it. You might experience a moment of guilt. But the mere presence of the label on the packaging does not physically prevent you from tearing open the wrapper and taking a bite.
Not at all.
The workflow of consuming the candy bar is entirely unimpeded by the transparency of the data. And Paper Trail functioned exactly like a nutrition label. It showed the user the cognitive junk food embedded in the AI's answer, but it fundamentally lacked the structural friction to stop them from consuming it.
That analogy perfectly isolates why passive warnings in AI interfaces are destined to fail. If the goal is actual workflow integrity, the solution at the artifact layer cannot just be a prettier citation list or a color-coded confidence score or a little red warning box.
What is the solution?
The solution has to be forced adjudication.
Forced adjudication. Walk me through the mechanics of that. What does that actually look like in a software environment?
It requires a massive paradigm shift from passive display to active blockage. A generated claim must structurally carry its entire evidence state and its contradiction state.
Okay.
Furthermore, as another researcher named Gilda points out, it must carry its expiry condition because empirical evidence expires over time.
Right, things change.
And critically, the software workflow itself must literally refuse to allow the user to click approve, merge, or forward until the contradiction register is manually, cognitively engaged with and cleared.
So the button is not just red. The button is entirely dead.
It has to be dead. If you do not engineer a physical roadblock into the interface, the momentum of confidence debt will simply slip right past the warning label. The user will acknowledge the risk and forward the email anyway.
I want to pause on Gilda's concept of temporal validity for a second, because it really illustrates how insidious this debt can be in long-term enterprise environments.
Yeah, let's explore that.
Imagine your AI system recommends migrating to a highly expensive database architecture, and it bases this recommendation on a rigorous analysis of your current server traffic. You verify it, you approve it.
Seems fine.
But 3 years later, your user base has grown by a factor of 10, and your data structures have completely changed. The original evidence has expired. If your decision recording software didn't structurally retain the raw support relations and attach an expiry condition to that recommendation, your engineering team is basically operating on expired confidence. They treat the old summary as gospel, oblivious to the fact that the tectonic plates underneath it have totally shifted.
The summary remains aesthetically true, but the reality it describes no longer exists.
Exactly.
And this is exactly why securing the first gate-establishing non-negotiable claim auditability at the artifact layer is the prerequisite for everything else.
Okay, so let's run a thought experiment here. Let's imagine a scenario where an organization actually listens to this. They overhaul their entire data pipeline. Gate 1 is completely secure.
I'm tracking.
Every single claim generated by an internal model is violently auditable. No polished summaries are allowed to exist without mandatory contradiction clearance. The engineering team is thrilled. The system is structurally sound.
A rare utopian vision in enterprise software.
It really is. But then, executive management inevitably enters the conversation.
Ah, right.
And a VP does not have the time or the inclination to read a 40-page contradiction ledger. Management demands compression. They want a single, clean, easily digestible dashboard score to justify to the board why they are firing a legacy vendor and deploying this AI across the entire customer service division.
And this brings us to the second massive trap, the second gate reliability release at the evaluation layer.
Their dashboard score.
Exactly. The evaluation layer is arguably the most dangerous point in the pipeline because its entire structural purpose is to take massive, chaotic, high-dimensional complexity and crush it down into a simple number.
Right.
That compression makes those numbers incredibly useful for rapid decision-making, but deeply existentially dangerous if the limitations of the metric are misunderstood. Because a single dashboard score is, by definition, the ultimate polished summary.
Let's look at the Talbench study on retail support agents that the post highlights, because it perfectly demonstrates how a dashboard score can actively deceive an organization.
Yes, the Talbench study is eye-opening.
So the researchers tested a highly capable frontier model, something on the level of GPT-4o on complex multi-step tool interactions. And we are talking about methy, real-world tasks here.
Like navigating a convoluted CRM.
Right. Dealing with frustrated users' vague inputs, looking up an order history, and successfully issuing a partial refund without breaking corporate policy.
Tasks that require genuine reasoning, context retention, and system navigation.
Exactly. And the model scored a 61% success rate on its very first attempt. In the benchmarking world, this metric is known as pass at 1.
Okay.
Now, if I am a customer service director looking at a dashboard, a 61% success rate on highly complex, multi-step tasks on the very first try sounds like an incredible foundation. It suggests a baseline capability that justifies an immediate pilot program.
It heavily implies that the system possesses the underlying reasoning capacity to do the job.
But then the Talbench researchers introduced a twist that completely shattered that illusion. They shifted the operational question.
What did they ask?
Instead of asking, can the model stumble its way to the finish line once? They asked, can the model be trusted to execute this task consistently over repeated sequential runs?
Well,
They shifted the metric from pass at 1 to pass 8, requiring the model to successfully complete the sequence 8 times in a row.
And what happened to that robust 61% success rate?
It collapsed. It plummeted to under 25%.
A drop from 61% to less than 25%. That is massive.
Massive.
And what is vital to understand here is that the model's core mathematical capabilities did not change between those two tests. Its parameter count didn't shrink. It didn't suddenly forget how to parse JSON.
So what happened?
What happened was that the metric finally revealed the massive hidden chasm between isolated lab capability and operational reliability.
The mechanism of failure here is so fascinating. Pass at 1 simply measures whether the system can find a successful path through the labyrinth once, often through sheer probabilistic luck. But repeated run reliability pass 8 exposes the compounding nature of AI errors. If the model makes a tiny contextual mistake on step 2, that error poisons the context window for step 3.
Which leads to a massive hallucination by step 6.
Exactly. The system isn't scalable enough to walk the path without eventually tripping over its own generated context. And if an executive takes that 61% pass at one score, puts it on a massive PowerPoint slide, and uses it to justify a massive deployment, they're literally converting a clean lab score into massive confidence debt.
Because the deployment strategy has completely outrun the underlying evidence of reliability.
Yes.
The score measured one-shot completion under pristine lab conditions. It did not measure how the system handles repetition, edge cases, or infrastructure faults. And this specific vulnerability is why the post introduces Gupta's reliability bench framework.
Ah, yes, the reliability envelope.
It is a brilliant mental model for forcing organizations to abandon flat metrics.
Let's really dig into the mechanics of this, because it provides a much-needed vocabulary for evaluating agents beyond the standard leaderboard hype.
Gupta argues that reliability is not a flat percentage point. It is a multidimensional surface area. They defined true operational reliability as an envelope represented by the formula RK, epsilon, lambda.
Okay, let's unpack the variables, because equations can get abstract quickly. What does the K represent in a real-world deployment?
The K stands for consistency. It asks the Pass 8 question. Can the AI execute this specific workflow 10 times in a row without inexplicably failing, getting trapped in an infinite loop, or slowly degrading its output quality?
Okay, so capability proves it can do it once.
Right, and consistency proves the architecture is robust enough to handle the grind of repetition.
That makes sense. But what about epsilon?
Epsilon represents robustness to perturbation. This is the variable that accounts for the messy, chaotic human element.
The wild cards.
Exactly. In a lab benchmark, the prompt fed to the model is perfectly spelled, syntactically clear, and logically ordered. But in the real world, the user is typing frantically on their phone while walking to the subway. The text is full of typos, slang, and weird phrasing.
So epsilon asks, does the AI still seamlessly recognize the core intent? Or does that tiny variation in input completely derail its logical routing?
Epsilon measures the agent's ability to survive reality.
I love that phrasing. Survive reality. And the final variable, lambda.
Lambda is fault tolerance. This evaluates how the agent reacts when the external technology it relies on breaks down.
Give me an example.
Say your customer service bot tries to call the Stripe payment API to issue a refund, and the API times out or returns an unexpected 502 error. How does the agent respond?
Right. Does it recognize the failure, pause, and attempt a retry protocol?
Does it gracefully escalate the ticket to a human manager? Or does it hallucinate a success message, tell the customer the refund is processed, and leave you dealing with an incredibly angry customer 2 weeks later?
This framework is just infinitely more valuable than a generic 95% accuracy claim on a vendor's website. It explicitly forces the engineering team to measure the system's behavior under sustained stress. And this connects perfectly to another massive risk at the evaluation layer, which is the concept of long horizon decay and trajectory drift.
Yes, the 2026 work by Lee on canonical path deviation. This is where the physics of LLMs really start to fight against long-term autonomy.
A really useful way to think about trajectory drift is to imagine you just bought a used car. Mechanically, the car runs fine, but it has a very slight alignment issue in the front tires. The wheels pull to the right by maybe 1 degree.
Just a tiny, barely noticeable pull.
Right. Now, if you are just driving 1 mile down a straight road to the grocery store, which represents a short pass at one task in the AI world, that alignment issue doesn't matter at all. You unconsciously hold the steering wheel straight, you get to the store, and you declare the car to be 100% reliable.
Because the flaw is entirely masked by the brevity of the task.
Exactly. But now imagine you take that exact same car on a 500-mile road trip across the country. That is a long horizon autonomous task. Over those 500 miles, that tiny, almost imperceptible 1 degree pull to the right starts to compound.
Your arms get tired.
The physical effort required to keep the car straight increases. Eventually, your arms get tired. You lose focus for 1 second to change the radio station, the drift takes over, and suddenly you find yourself in a ditch.
The system experiences what researchers call meltdown onset.
Yes.
Yeah.
The car didn't suffer a catastrophic mechanical failure. The engine didn't explode. The drift simply compounded over a long horizon until it exceeded your capacity to correct it.
And Lee's research found that this is exactly how highly capable AI agents fail in complex environments.
Wow.
Because LLMs are probabilistic sequence generators, every single step they take carries a minute chance of selecting a suboptimal token. Over a long horizon, these tiny errors accumulate in the context window. Their reasoning trajectories slowly, step by step, diverge from the canonical paths that successful runs follow.
The agent just slowly, confidently veers into the ditch.
That analogy perfectly captures the danger. A single flat benchmark score cannot possibly inform a deployment team when an agent is going to transition from coherent, logical progress into unrecoverable, hallucinatory drift. Which leads us to the fundamental evaluation rule for the second gate. Deployment must never be based on raw capability scores. It must be treated as governed execution inside a rigorously proven envelope.
Bounded autonomy.
Precisely. Teams that successfully deploy autonomous agents in high-stakes environments don't just hand the API keys to the entire production database based on a 90% leaderboard score.
That would be insane.
It happens. But they shouldn't. They need to legally and technically restrict what the AI can touch. They implement aggressive monitoring. They recognize that release confidence belongs strictly to the defined RK epsilon lambda envelope. And the moment the task leaves that envelope, autonomy is revoked.
Okay, let's look at the pipeline so far. We have secured the artifact layer. No lying summaries are allowed to exist without a contradiction register.
Gate 1 secure.
We have secured the evaluation layer. No inflated dashboards, only deployments within a strict reliability envelope.
Gate 2 secure.
But inevitably, in almost every high-stakes corporate workflow, the AI system eventually hits a ceiling. It completes its bounded task, and it has to hand its final output to a human reviewer for ultimate sign-off.
Ah, yes, the tech industry's absolute favorite catchphrase. The human in the loop.
Exactly. It's the ultimate fail-safe, right? But what if the first two layers, operating over months or years, have invisibly hollowed out the cognitive capacity of that human reviewer?
This is where things get genuinely unnerving.
This brings us to the final vulnerability, the third gate co-audit at the human layer. And I have to say, the cognitive psychology findings in this section of the post are just terrifying.
They really are, because they challenge our fundamental assumptions about human-computer interaction. We have to ask a very uncomfortable question. How does the constant daily presence of highly confident, highly fluent AI profoundly alter the cognitive ability of the human relying on it? If a software artifact is wrong, you can just rewrite the script and generate a better one. But human correction capacity, the actual cognitive muscle required to look at a complex system, notice an anomaly, and debug it, is biological. It is incredibly slow to rebuild once a workflow stops exercising it.
The erosion of human skill. The post brings up a study by Lewis et al., and the results are a gut punch to anyone managing a team right now.
Walk us through it.
They found that providing human workers with just 10 minutes of highly capable AI assistance drastically improved their immediate short-term task performance.
So in the short term, the AI delivered exactly what was promised, the workers got the job done faster, and the quality of the output looked better.
But the shadow cast by that success was devastating. That exact same 10 minutes of assistance significantly reduced the workers' later independent performance when the AI was removed.
Wow.
And even more concerning, it dramatically increased their task abandonment rate. When they were forced to tackle a difficult problem without the AI, they simply gave up faster.
The underlying cognitive science here is crucial. The AI didn't just solve the problem, it changed the worker's baseline threshold for cognitive friction.
How so?
By bypassing the working memory struggle to find a solution, the AI prevented the brain from forming the neural pathways associated with persistence and deep problem solving. It literally eroded their cognitive endurance.
You see this dynamic even more clearly in environments that require deep, complex, systemic learning. The post highlights an incredible study by Shannon Tamkin on software developers who were tasked with learning a highly complex new Python library.
Oh, the behavioral split in that study between the engaged learner and the contractor is one of the most important concepts in modern AI adoption.
Yes, let's break that split down. The researchers divided the developers into two groups. Group A actively used the AI to explore concepts. They asked questions, they wrestled with the code alongside the AI, they experienced frustration, they hit roadblocks, but through that friction, they actually built a robust mental model of how the library functioned.
They treated the AI as a sparring partner.
Exactly. And Group B treated the AI like an outsourced contractor. They completely bypassed the learning process. They just pasted in the prompt, build this specific module for me using this library.
And the AI just did it.
The AI spit out the Python code, they copy-pasted it directly into their editor, the code compiled perfectly, and they moved on to the next task. The immediate productivity of Group B was phenomenal.
But there's always a catch.
3 weeks later, a bug appeared in that exact code. Group A knew exactly how to navigate the architecture to fix it. Group B was staring blankly at a black box. They had completely lost the skill needed to debug their own systems because they had optimized entirely for speed and bypassed the friction.
This reveals a profound truth about knowledge work. Friction is the actual training load that preserves correction capacity.
Say that again, because that's huge.
Friction is the actual training load that preserves correction capacity. When you remove the friction from a workflow, you are simultaneously removing the training stimulus. Over time, the muscle atrophies. And this dynamic perfectly sets up Sadiq's concept of the competence shadow.
The competence shadow. I was trying to visualize this concept while reading the post because it is so abstract but so dangerous. Imagine you were standing in front of a massive pitch-black warehouse and you are looking through a tiny keyhole in the door.
Okay, I picture it.
The AI system is that keyhole. It provides a brilliant, highly focused beam of light that perfectly illuminates one specific stack of boxes inside the warehouse. You can see those boxes with perfect clarity. You can study them, you can write a detailed report on them, you can organize them. You feel completely in control of the environment.
Because the interface provides an illusion of total visibility.
But you have absolutely zero idea if a tiger is standing 1 inch outside the frame of that keyhole.
Right.
And here is the truly terrifying part of the competence shadow. Staring harder through the keyhole will never, ever reveal the tiger. What the AI filtering system curates out of your view cannot be recovered by staring really intently at the polished summary of what remains in your view.
That is the essence of the competence shadow. It encompasses both what the system explicitly tells you and, crucially, the vast universe of data that the system quietly prevents from ever reaching your desk.
Right.
If an AI safety tool is scanning a code base and it misses a critical vulnerability, the human engineer reviewing the AI's curated summary will inevitably miss it too. Not because the engineer is lazy, but because the vulnerability simply isn't in the summary to be reviewed. The human's competence is entirely overshadowed by the machine's curation.
Which makes me want to push back aggressively on the tech industry's absolute favorite defense mechanism. Every major AI company, when confronted with reliability issues, points to the same failsafe. They say, don't worry, these models aren't fully autonomous. We always keep a human in the loop. The human makes the final call.
Yep, the classic line.
But based on the erosion of persistence we just discussed and the blinding effect of the competence shadow, isn't human in the loop just pure, unadulterated security theater?
It is worse than security theater. It is a liability shield.
A liability shield.
The industry relies heavily on the human-in-the-loop concept to absorb legal and public relations liability when things go wrong, not to provide genuine structural oversight. Think about the reality of the workflow. You have a tired, overworked human staring at a brilliantly fluent, deeply confident AI output through a keyhole.
At 4:45 p.m. on a Thursday.
Exactly. That is not a governance mechanism. That is a rubber stamp. The workflow itself has, over the course of months, systematically trained that human into a state of passive acceptance.
So if the human in the loop is broken, how do we fix it? We know that adding more passive warning labels than attrition labels doesn't work. The trust behavior gap proves that. So what is the actual solution at the human layer?
The post outlines a structural solution called Co-Audit. This was defined by Gordon and their team in 2023. Co-audit tools represent a massive paradigm shift.
How so?
They are software interfaces designed explicitly and fundamentally for the act of checking AI-generated content after it has been generated. The vital realization here is that the human audit task cannot just be an afterthought. It must become an explicit, structured interface of its own. It requires the implementation of cognitive forcing functions.
Ghosh's study on plan-focused prompts is a brilliant example of a cognitive forcing function in action.
Tell me about it.
They found that if you simply ask a human to mentally imagine alternative solutions before accepting an AI's answer, it does nothing. But if you literally force the human to pause, engage their motor skills, and physically type out their own assumptions or their own analytical outline before the software allows them to see the AI's generated text, it significantly reduces over-reliance.
You have to force them to execute the cognitive labor. Asking people to casually imagine alternatives feels nice, but user comfort is not the target in an audit workflow. Reviewer action is the target. The interface has to drag them out of passive consumption.
And this ties into the broader necessity of moving away from recommendation-first interfaces toward hypothesis-driven interfaces.
That's a crucial distinction.
Right. A standard ChatGPT-style interface is recommendation first. It gives you one highly confident, beautifully formatted answer, and essentially asks you to accept or reject it. That architecture breeds passive acceptance.
Because rejecting it is too much work.
Exactly. A hypothesis-driven interface forces active comparison. It presents the AI's conclusion, but it actively shows the human the evidence for the claim and simultaneously drags the omitted counter-evidence out of the competence shadow and forces it right next to the text.
It doesn't let the counter-evidence fade away. It keeps the dissent alive and glowing on the monitor long enough for the reviewer to actually be forced to engage with it. It structurally makes rigorous correction more mandatory than passive acceptance.
Okay, we have spent a lot of time examining these three vulnerabilities in isolation: the artifact layer, the evaluation layer, and the human layer. But as we look at the broader implications, we have to understand how this all comes together, because in the chaotic reality of a corporate environment, these failures don't happen in a vacuum.
They finance each other.
They compound into a cascade, and understanding this cascade is how you understand why massively profitable, highly resourced companies can completely lose control of their operational reality.
Let's walk through the Fintech cascade that the post describes, because it really brings the entire abstract theory of confidence debt to life.
Let's do it. Imagine a massive financial tech company that decides to use an AI agent to audit its daily transaction compliance.
Okay, high stakes.
Step 1. The cascade begins at the artifact layer. The AI generates a beautifully polished, comprehensive summary report of the day's transactions. But the tracing is flawed. It missed a series of irregular international wire transfers. Because the summary looks so professional, it inherits unearned confidence. Nobody checks the messy raw transaction logs.
And right there, the confidence debt is born at gate 1.
Step 2. That flawed, unverified summary gets fed into an automated evaluation tool to determine if the AI system is ready for wider deployment. Because it's a beautifully written, syntactically perfect summary, the evaluation tool gives it a 95% dashboard score.
Oh, man.
The executives see that 95%. They don't see the caveats, they don't look at the RK, epsilon, lambda reliability envelope, and they certainly don't look at the raw data. They deploy the system to run autonomously based entirely on that single compressed vanity number.
The debt balloons at gate 2. The deployment strategy inherits massive confidence that the underlying evaluation never actually earned.
Step 3. The system is now running live, and it relies on a single human compliance reviewer to sign off on flagged transactions. But over the past 6 months, the frictionless, highly confident AI has completely eroded this reviewer's persistence.
The muscle atrophy.
Exactly. The system is operating autonomously. The generated answers always look perfect. The dashboard says the system is 95% reliable. The human is staring through the keyhole, assuming the machine sees everything.
Yeah.
The irregular wire transfers, the tiger, are actively draining accounts, but the human never sees them.
And the system crashes, the regulatory fines hit, the company's reputation is destroyed, and everyone asks how it happened.
Boom. It is a compounding systemic disaster. But I want to play the skeptic for a second, because this is a massive theory.
Okay, hit me.
Let's say I'm a researcher who has been studying human-computer interaction for 20 years. If I am looking at this fintech cascade, I might say, isn't this just an overly dramatic, highly academic way of saying people trust machines too much? Is confidence debt really a new, distinct theory? Or is it just the classic concept of automation bias rebranded for the generative AI era?
That is the absolute most important pushback to address, and the post calmly and meticulously defends the theory against exactly this critique.
How so?
The authors acknowledge the rival frame, which is formally known as appropriate reliance. Appropriate reliance is a massive, well-established field of study, and it essentially proves that human reliance on machines acts like a pendulum.
Right. The post mentions the contrasting medical studies to illustrate this, the radiologist study versus the pathologist study.
Exactly. On one side of the pendulum, you have a study of expert radiologists who actually under-relied on a highly capable AI system designed for diagnosing prostate cancer. They routinely ignored accurate, life-saving advice from the machine because they were too inherently skeptical of its methodology.
They didn't trust it.
On the other side of the pendulum, you have expert pathologists who exhibited massive automation bias. They over-relied on incorrect machine advice, letting flawed computational pathology sway their own expert judgment. So the appropriate reliance literature proves that yes, at the moment of decision, people can be either too trusting or too skeptical.
So if the appropriate reliance framework already explains that humans struggle to calibrate their trust in machines, why doesn't that framework absorb the theory of confidence debt? Why do we need a new term?
Because of the timeline and the structural depth of the workflow, appropriate reliance has a strictly micro focus.
Micro.
It asks, how does a human weight machine advise at the exact localized moment of decision? It focuses entirely on the user interface and the psychological calibration of the user right when they're hovering over the approve button. Confidence debt has a macro focus. It looks at the entire structural workflow that preceded that moment over weeks or months.
That is a crucial distinction, micro versus macro.
Think back to the Fintech Cascade. Even the most diligent, brilliant, perfectly calibrated human compliance officer will completely and utterly fail if the evidence they receive at step 3 was fatally overcompressed, stripped of vital caveats, and hallucinated miles upstream at step 1.
Right. If the input is garbage, their judgment doesn't matter.
If the summary lied at the artifact layer and the benchmark was mathematically inflated at the evaluation layer, the human never stood a chance. The workflow failed them long before they even opened the email. Automation bias is about the psychology of the user. Confidence debt is about the architecture of the system. It is about the speed of trust versus the speed of evidence.
The speed of trust versus the speed of evidence, that phrasing perfectly encapsulates the danger. Confidence debt is structural. It's not just a psychological quirk of the end user that can be fixed with a training seminar. It is a flaw in the pipes of the organization itself.
Baked into the very infrastructure.
And I appreciate that the post is very nuanced about the epistemic status of this theory. They don't claim that the sky is falling in every single instance. They note there is no universal, one-size-fits-all threshold for this debt.
Context is everything. A low-stakes marketing email can safely carry a massive amount of confidence debt. If an AI hallucinates a typo in a promotional code or slightly misinterprets the tone of a brand guideline, the blast radius is negligible. You just send out an apology email the next day. But an irreversible medical diagnosis, a structural engineering load calculation, or a $1 million financial transaction cannot carry a single cent of confidence debt.
Because the cost of correcting the error downstream, when the debt finally comes due, is catastrophic.
Precisely. The interest rate on unverified trust in high-stakes environments is ruinous.
This brings us to the end of our deep dive. We have covered an immense amount of ground today, moving from Ethereum code bases to cognitive psychology. Let's distill everything we've discussed into the absolute core doctrine, 3 non-negotiable rules that you, the listener, can take back to your engineering teams or management boards tomorrow to stop this compounding vulnerability.
Rule number 1. Claim auditability before trust. This governs the artifact layer. No generated claim should ever be allowed to move downstream unless its exact RUDL data and a recorded contradiction register travel inextricably alongside it.
The software must enforce this.
The approval button must be dead until the evidence is manually inspected.
Rule number 2. Reliability release before deployment. This governs the evaluation layer. A flat benchmark score, a pass at one metric, is an interesting lab result. It is not a deployment argument.
You only grant autonomy to a system inside a rigorously measured envelope that accounts for repeated runs, user chaos, and long-horizon trajectory drift.
And rule number 3. Co-audit before human acceptance. This governs the human layer. You cannot hand a tired human a polished, aggressively confident answer and expect them to catch systemic errors through sheer willpower.
You must actively design structured, hypothesis-driven software tools that drag omitted counter-evidence out of the competent shadow and forcefully inject cognitive friction back into the review process.
Which leads us to a final, lingering paradox the post leaves us with. And it's something I really want you to mull over as you look at the software tools you use every day. The entire promise of the modern tech industry, the trillion-dollar dream that AI companies are selling us, is seamless, zero-effort, frictionless productivity.
The seductive dream of never having to do the grueling cognitive labor again.
But everything we have uncovered today suggests that surviving and thriving in the age of generative workflows requires the exact opposite approach. Paying down confidence debt requires us to intentionally, deliberately design friction and structural resistance back into our systems.
It must be structurally harder to approve a document, harder to deploy an agent, and harder to trust an output.
It raises a profound, fundamental question about the future of work. Are true, verifiable reliability and frictionless automation fundamentally incompatible?
I think when it comes to high-stakes reality, they just might be.
So the next time it is 4:45 p.m. on a Thursday, and your brain feels like cotton, and a beautifully formatted, flawlessly pristine summary drops into your inbox, take a breath. Recognize the overwhelming physiological urge to just let your shoulders drop and hit forward. Remember the danger of borrowed trust, and invite the friction back in.
Force yourself to look at the spreadsheet. Stop the cascade before it starts.
Thank you so much for joining us on this journey today. Keep questioning the polished surface, demand the receipts, and as always, keep diving deep.